This is my course project for managing machine learning projects. My name is Helin. So here's our problem. We are a product review site. Product owners only let site owners review their product if the review leads to site visitors navigating to the product owner's site or a retailer site where the product is being sold. So our project topic, motivate a site visitor to click on a product link on our site. This is an attractive opportunity for a machine learning-based solution because there's definitely a problem. We're a product review site and we need site visitors to click on product links so that more product owners will let us review their products. This is definitely a problem machine learning can help solve. If we can predict when a site visitor is likely to have high levels of interest in a specific product or product category, and therefore is more willing to click on a product link, we can make sure the site visitor sees that product review. There's tons of user data activity to use to validate this. Solving the problem definitely matters. The business impact is very high because this solution supports our site's mission. It's also a highly feasible solution because we own all the user engagement data. Therefore, data access is easy, and we happen to have all the resources to bring the solution to life. So according to the CRISP DM process, here's how we define the problem. Who has the problem? Us, the site owner. What is our problem? Well, we need site visitors to click on product links. Why does it matter? This is how the product owners decide whether allowing our site to review their products is beneficial or potentially profitable for them. So how is it solved today? If a site visitor engages with a similar product in the last 30 days, our recommendation engine recommends other products in the same category to the site visitor. Our definition of success is defined as the outcome being increased revenue for product owners, where more product owners will automatically want our site to review their products. The expected output metric is precision. We want to increase the likelihood of predicting a true positive. To identify potential relevant factors, we need to speak to product owner partnership management teams, as well as user experience management teams. The solution validation plan looks like this. Our solution concept assumes site visitor product engagement patterns exist, meaning there's a certain order to which a certain batch of site visitors engage with certain product categories within a certain time period. So our iterative experiments will look something like this. Our first iteration will exist to validate our understanding of the problem and make sure stakeholders align with our proposed solution. Our second iteration will validate assumptions for the solution and make sure it's feasible. So we want to do things like analyzing the data to validate that there is a significant volume of site visitors with similar product engagement patterns. Our third iteration will validate data to determine whether the model inputs and outputs can be clearly defined. For example, we'd want to create a heuristic rule based on recurring engagement patterns, like site visitors that engage with products 1, 2, 3, 4 in that order within a 20-day time period will engage with product number 5 in the next 5 days. Want to confirm this with data, so on and so forth. Now, from a system design perspective, looking at cloud versus edge, we know that latency definitely matters. It also requires a site visitor to have a network connection to even get on our site. There's a possibility that site visitors may take data privacy as an issue, which means the cloud approach makes the most sense. However, we could take a hybrid approach where the model runs in the cloud and most commonly pre-computed predictions live on the site visitor's device for quick lookups. Between the two learning options, we choose online learning. The model needs to be able to adapt in real time to changing environments. It's also very okay if the model only retrains on more recent sets of data. For predictions, we choose online predictions. It's crucial for this product that real-time predictions are provided to an actively engaged site visitor. For potential risks, once the model is in production, well, the training serving skew can be an issue if compared to our training environment, there aren't as many site visitors with similar patterns in the production environment. However, this can be caught immediately, and we can just go back to the drawing board. Excessive latency cannot be an issue. If it does become an issue, we need to go back to the drawing board. The whole point of this product is real-time recommendations. However, because we choose online learning and online predictions, the probability of this happening is very low. Data drift is definitely a possibility. However, by choosing online learning, we assume we can mitigate any potential problems. The biggest problem in the MIST is concept drift. This is a huge potential risk that we need to monitor for, because if site visitor product engagement patterns change significantly, the model will need to be updated significantly and immediately. Thank you for listening.